Section 4 of Chapter 4 is more factoring. And I must tell you, I have a love-hate relationship with factoring because remember in Section 3 I said it involves trial and error. And as frustrating as trial and error is, it's also like a puzzle. So today the puzzle gets just a little more difficult. Instead of an easy an easy puzzle, we've got a jigsaw puzzle now. So we're going to solve quadratic equations in the form of ax squared plus bx equals c. So the difference here is that we're going to have a coefficient in front of our x squared term, whereas we didn't have that in the last section. If you'll look, I've listed out the steps that you're going to take in order to factor these. But what I'm actually going to do is we're going to start with the bottom step, and we're going to talk through each step from the backwards. So So what we're going to learn first is making sure that we're using that FOIL backwards, just like we did when we had ax squared plus bx plus c equals 0. The difference is now we have a term in front of our x squared, and it just adds just a little bit more of a dimension in our puzzling. So what we're going to do, if we're factoring 3x squared plus 10x plus 8. Once again, we simply want to decide what did we multiply together, what binomials did we multiply together to get this trinomial. So before, we simply put an x in these two spots because it was x times x equals x squared. Well, in this case, we want these first terms to equal 3x squared. And this actually is a simple one because the factors of 3 are just 1 and 3. So we know that we're going to have 3x times x. 3x times x will give us x squared. Now the third term is 8, and so with that, you know we're going to multiply these two terms, the last terms, in order to get 8. And so our choices are 1 times 8, 2 times 4, and that would be it. So when we multiply those, we know that the sign on that is a positive. And remember, if the third term is positive, then the signs in our binomials are going to be the same. And the sign that you would choose is the same as the sign in your second term, your second monomial. So in this case, the signs are the same and they're both negative. So we can immediately put two negative signs. And because they're both negative, we're simply going to add these middle terms together to get the 10x. So we use trial and error. We say, oh, I don't know, let's say, what if we put 1 here and 8 here? And we said, oh, you can check it by saying 3 times 8 is 24, and negative 24x minus x. Ooh, that's negative 25x, that's too big. So you might end up having, keep an eraser handy. You might have to check and do that jigsaw puzzle a few times and try a few pieces, and if it doesn't work, that's okay. That's part of this process of factoring. So then you look through and say, well, let's try, okay, the 1 and the 8, the difference is pretty big. So let's try a 4 here and if I put 4 here, I can immediately see, 3 times 4 is 12. That's already too big. So let's put the 2 here and the 4 here. So then we take 2 times 3 is 6x, so negative 6x. And the inside terms are negative 4 times x. Negative 6 and negative 4 together make 10x. So you can see that it is a bit of trial and error, and that's okay. We can work with it. This next one is 6x squared plus x minus 15, and you'll see this third term is negative. So in this case, we got a couple of different things going on in our puzzle. Because we know that the signs are going to be different. We're going to need one positive and one negative in our second term, in our two binomials. We also can see that the number in front of the x squared term is a number that has more than just one set of factors. So we can multiply 1 times 6 to get 6, but we can also multiply 2 times 3 to get 6. So we need to keep those combinations in mind and then move to the 15. 15 is 1 times 15 and 3 times 5, and those are only options there. So what we're trying to do here is we've got to have one of these sets in these first terms of our binomial to equal the 6x squared, and one of these sets, one of these pairs of numbers in our last terms to multiply together to get a negative 15. Then the combination needs to combine to make positive 1. So you can see that if we want a positive 1 in the middle here, probably we're not going to use a 15 because that's such a large number. We would need a large number in our first combinations to counter that. Because we are going to be subtracting, so we need the difference to be 1, the difference between the two products. So let's try 3 and 5 here. And then we're going to look at the 1 and the 6 and the 2 and the 3. So let's just put some in here. Let's try 2x here and 3x here. And we'll take 2 times 5 is 10x for the outsides, and the insides are 3 times 3 is 9x. If one is positive and one is negative, we want the larger one to be positive, so we want the 9 is smaller, so we want it to be negative. So that would indeed be 10x minus 9x would give us 1x in our original. So in order to make this true, the 9x has to be negative. So 3 times 3, we've got to put the negative here to make negative 3 times positive 3 is the negative 9. So this one would be positive. So why don't you try, let me give you a couple to try. (7x squared minus 20x minus 3). And you can start working on those, maybe put them, pause the video and try to work them on your own and then come back. All right, so pause now and work it on your own, and once you get an answer, come back. All right, now I hope you did that already, because here we go. You're going to multiply 2 binomials together to get this. This one is actually a fairly simple one because 7 just has 1 times 7 and 3 just has 1 times 3. So we just need to know the combination of the two. So let's just put in 7x and x. 7x times x is our x squared. And we want 3 to be 1 and 3. 1 is going to be positive and 1 is going to be negative. And we want our answer to be negative 20. So I know that if I take 7 times 3 for my outsides, I'm going to get 21. And 1 times x is just an x here. So if I make my 21x negative and our positive 1x, then we'll end up with a negative 20x. So we want this one to be negative and this one to be positive. 7x plus 1, x minus 3 is our factored equation or expression. So hopefully you got that. Let's move on to the next one. Same type of thing here. 5 is just 1 and 5. 3 is 1 and 3. So this one should be quite simple. So we've got 5z and 1z. And because this is a positive third term, our signs are going to be the same in our binomials. And our second term is positive, so we're going to have 2 positive terms. And we want those to add together to get 16. So we need 3 times 5 to be 15z. Plus 1 more z to equal 16z. So this is our final answer here. All right. So if you're finding that, oh yeah, I'm getting this, so then keep going. If this is tripping you up, then go to page 260, I believe it is. Go to page 260 and there's more guided practice. There's more examples. Look at those. Maybe rewind the video and review that a little bit more. Because let's move on to, if we go backwards through our steps, so using FOIL backwards, also what you need to do is you need to check for those special patterns. If you'll remember the special patterns that we talked about in section 4.3, those special patterns have to do with squared terms. If you find that your first and your last terms are both squared, then you very likely will have one of these special products, and you just need to check for that. So let's look at a couple of different ones. All right. So if you're looking at these expressions, and in this case, this is just a binomial, and we happen to know that, oh, look, x is squared, 81 is a perfect square, and 25 is a perfect square, and they are indeed subtracted between them. So if you can remember back to your difference of two squares, if you have a perfect square minus a perfect square, you can quickly and easily see, oh, I want the square root of 81 is 9, the square root of x squared is x, the square root of 25 is 5. I'm going to have 9x plus 5, 9x minus 5. And then when you multiply it out, the 9x squared is 81x squared. The last term we just said was the same. So then you have a negative 9x times 5 and a positive 9x times 5, and that's going to drop out. So there's your final term. Same thing here, or not the exact same thing, but you do have a perfect square because 49 is a perfect square and 64 is a perfect square. So if your first and last terms are perfect squares, check them. Square root of 49 is 7, so 7x. Square root of 64 is 8. And this is a positive term, so put a positive in between and then check your middle term. Because remember, the middle term is 2 times a times b. So we're going to take the two parts of our binomial, 7x, and multiply it by 8. 7 times 8 is 56. And 2 of those is indeed 112. Try this one on your own. Where did it go? 9y squared plus 12y plus 4. And one more, 25x squared minus 80x plus 64. Try them on your own. Pause it, try it, and then come back. 9 is squared, so the square root is 3, so 3y plus 2, square root of 4 is 2, and then check the middle term to be sure. 2 times 3 is 6, and 6 times 2 is 12y, so that is our factored term. Here we go with this one. Square root of 25 is 5, so 5x. Square root of 64 is 8. And because that middle term is negative, if you'll remember back, if the middle term is negative, then you're going to have your binomial is going to be an a minus b. So then when you check it, 5 times 8 is negative 40, and 2 of those is negative 80x. All right, so now you know how to factor using FOIL. You know how to use your special products. Let's do the last step is, the last step that I'm going to teach you is actually the first step that you need to do. When you're looking at a trinomial to factor, you want to first see, is there anything in all of the terms, in all of the monomials, that will factor out before you even begin? So with 3x squared minus 300, we can look, before you start trying to decide, ooh, what can I divide out of here? Look to see, is there anything in both of these individual monomials that you can divide out? So we can see that 3 and 300 have a 3 in common. So what I can do is I can divide both parts by 3 and say 3 times x squared is 3x squared, and 3 times 100 is 300. So we can pull out part of that in just a monomial. So then once we've done that, then we check to see, okay, will this factor further? And in fact, this is a perfect square minus a perfect square. So don't forget to keep the coefficient in the front. Don't lose that, because that is part of your factored answer. So x squared is x times x, and 100 is 10 times 10. And because it's because there's nothing in between, we've got a positive and a negative. And there is your final answer. 3 times the quantity of x plus 10 times the quantity of x minus 10. In this one, you can see that there's a 7 in common between 7 and 63. A t squared and a t also has a t in common. So we're going to pull out the whole 7t. But also one more thing, when we're factoring, we just typically want the first variable in our binomial to be positive, or in a trinomial if it's the t squared. We want that to be positive. So we're going to pull a negative 7t out so that our first term is positive. So negative 7t times t is negative 7t squared. And then because we pulled out a negative 7, this is now positive. And 7 times 9 is 63. And 7t times 9 gives you the 63t. So now what we have left in here is negative 7t times the quantity of t plus 9. And you can see that there isn't a squared term in that anymore, and so we're finished. There's nothing else in common. There's nothing else that can be pulled out. So this is the factored term. One more here. 8m squared plus 28m minus 120. So you can look to see, 8, 28, and 120, they're all even. So we know that 2 will come out. They actually are divisible by 4. So take a 4 out of all 3. Don't forget, you've got to take it out of every monomial. If you don't take it out of every term, then you haven't done it properly and you won't get the right answer. So 4 times 2m squared plus 4 times 7m is your 28, plus 4 times negative 30. And so now you can see, okay, there's nothing else in common. We can't pull anything else out, but now we have one of those trinomials that we simply need to factor. So don't forget to move your 4 down. That is part of your answer. And now we're going to break it up using our backwards FOIL. We're going to find our binomials that we multiplied together. 2 is simply 1 times 2, and there are no other factors. So we're going to have one factor of 2m and one factor of just m. And then 30 is 1 times 30, 2 times 15, 3 times 10, and 5 times 6. And those are our options for in these 2 slots. And because it's negative, our signs are going to be different. So you can put one positive and one negative here and work it and then switch it if you need to. I kind of like to wait and determine what that sign is later. So let's just see, because we're going to have a difference, let's just try 5 here and 6 here. 2 times 5 is 10m minus 6m. Not quite big enough. Let's try switching them around. Let's try 5 here and 6 here. 6 times 2 is 12 minus 5m gives you your 7. We want the 12 to be positive and the 5 to be negative. So there's our signs. So our final answer is 4 times the quantity 2m minus 5 times the quantity of m plus 6. Let's see. I would like for you to do one more before I let you go. Negative 25y squared plus 60y minus 35. Try that one real quick. Pause it and come back. And here we are back. All right. So the things that are in common are 5. And because we want the y squared to be positive, we're going to take out a negative 5. And don't forget, if you took out a negative here, you've got to take out a negative here. So if this is positive and I took a negative out, now it becomes negative 12y. And I took out a negative here, so this one is a positive 7. Don't lose the negative 5. 5 is easy because it's just a 1 and a 5, so 5y on this side and a y on this side. 7 is easy because it's just 1 and 7. And because this symbol is positive, Both signs are going to be the same, and this indicates that they're both going to be negative. So if I put the 7 here, now I'm going to have 35, and that's too big. So let's put the 7 here, and then check it to be sure. Negative 5y on the outsides, negative 7y on the insides, and 5 and 7 are negative 12. So there's our final answer. So you can see it's really, it's just a matter of puzzle pieces and putting the right pieces in the right place at the right time. And then make sure to go back and check using that outside and inside and add them together. Check it each time and you know that you'll always get the right answer. And if it's not right, you back up and try it again. There's lots and lots and lots of examples. If you're not quite getting it, look at the examples in the book, look at the guided practice. We'll do lots of problems. This is one of those things that you get better as you practice. So let's get going.